Tengo el gusto de presentar a Christopher Alexis, de Trinidad y Tobago. Christopher Alexis es un oficial de investigación en el Departamento de Oceanografía y Procesos Costeros en el Instituto de Asuntos Marinos, con 13 años de experiencia asistiendo al gobierno de Trinidad y Tobago en diferentes acciones de instancias públicas y privadas y asuntos relacionados con la erosión costera. Christopher Alexis está especializado en ingeniería costera y geomorfología costera y utiliza esa experiencia para determinar las tasas de erosión y acreción de las costas alrededor de Trinidad y Tobago. Su pasión por la conservación marina lo impulsa en el Instituto de Asuntos Marinos a realizar trabajos de campo e investigaciones enfocadas en el monitoreo y la conservación costera. Adelante, por favor.
Hi, good morning, everyone. All right, so my name is Christopher Alexis, and I will be presenting on just giving a brief overview on the geomorphological changes at Bonas in Trinidad. This area was selected as one of the areas for an executive study from the Sandy Shorelines project that ACS actually helped to coordinate with the kind contributions from the South Korean government. So in conjunction with my research colleague, Iran Mohammed, we put this presentation together. So here we go. So the format of the talk, we'll give a brief introduction, side description. I'll go through exactly how we collected the data. We'll talk about some of the data collected and some of the findings and the recommendations from this period. So beaches, we all know, are depositional features, and they actually protect the coast by buffering against the impacts of coastal processes on the shoreline. They are dynamic, and it buffers against the wave energies at varying periods from summer and the North Atlantic winter, the Northern Hemisphere winter periods, where we experience larger wave energy with bigger waves that impact the coastlines, yeah? The shorelines are damaged, or they can experience impact naturally and from anthropogenic sources. So some of the objectives on the project is that we look to investigate the coastal processes that impact the shorelines around Trinidad, but namely for the Bonas area. This project is actually part of the larger coastal conservation project within the Caribbean region that focuses on coastal dynamics. The project started in the early 80s, so we have 40 plus years of data. So we have a strong historical, consistent data set that we can call on to analyze different parts of the shoreline around Trinidad and in Tobago. So we want to determine coastal erosion and accretion rates, which also helps with sustainable coastal development, especially around Trinidad. And we look at some of the stability status, well, focusing on Bonas today. So top left-hand corner, we have a diagram of the Caribbean region, just showing where Trinidad is in the red box in the bottom right-hand part of the screen there. So on the east, we have impact from the Atlantic Ocean, and from the west, we have the influence of the Caribbean Sea. Now, Bonas is located southwestern peninsula on the bottom left-hand corner of Trinidad here. So it is influenced by the outflow from the Orinoco coming up from the South American mainland, and also from the coastal processes that operate within the Gulf of Paria between Venezuela and the west coast of Trinidad. So on your left here, Trinidad, this is a coastal classification map, and our area of focus will be by the red arrow, the bottom left-hand corner. Some of you may not be able to see, but in the bottom left-hand corner here, And that area of shoreline is depicted with sandstone cliffs. So even though cliffs may sound very protective, they are susceptible to the impacts of coastal processes. Bottom right-hand corner, we have a close-up satellite imagery of the area of interest of Bonas. So these boxes, these red lines here, those are some of the stations that the Institute of Marine Affairs has along the shorelines. From ICONOS satellite imagery, 2007. So, just to keep this top right-hand corner there, that is just for context to show orientation. So we have different pictures here that depict the situations at the different stations, Station 1, Station 2, and Station 011. So the top photos show an easterly view, the bottom photos show a westerly view. So here, all of these photos were taken on a spring low tide, where we get the maximum exposure of the beach. So the water line on this area, well, at this point was actually about 4 meters from the mainland backshore cliff. At a spring high tide, the water actually hits Station 2 at the base of this cliff, yeah? And, well, Station 1 is most easterly, and just east of Station 1 here, we have a headland which would provide most protection to this station, yeah? The bottom of Station 3 here, that bottom photo, we actually see where the high water mark is just at the base of the berm where the fishermen place their boats. And this area, that region where the boats are, is about 8 meters roughly from the main road. And that main road in Bonas connects two very important fishing villages in Trinidad, namely Fullerton and Icacos. So this area, this community, this roadway is a vital connection for that community. So how did we collect the stuff? Top right-hand corner, we have Trinidad showing our IMA beach monitoring stations around the shorelines. The red dots show exactly where we have beach monitoring stations or benchmarks. And, well, Bonas, bottom left-hand corner, we have that, well, some red dots there. So we collect littoral data and beach profiles. So with the littoral data, as nearshore littoral data when we do the beach profiling. So wave height, wave direction, breaker height, longshore current, wind direction, wind speed. So some of the equipment we use are a compass, a digital anemometer that we can record in feet per second, meters per second. It's also a stop clock. We have a 100-meter fiberglass measuring tape. We have a 7.6 meter graduated metric staff, that is fiberglass. Also, we have a tripod and an automatic level. In addition to littoral data and the beach profiles, we collect sediment, so the grain sizes. And we collect sediments at 3 locations on the profile transect, at the upper beach, the mid beach, and the lower beach. And we use the Wentworth classification scale and also Folk and Ward parameters when we do sediment statistics. So for the littoral data that was collected between the 2011 to 2018 period, this is the precursor before the executive Sandy Shorelines project, yeah? So at these, you would notice 3 stations here, 1, 3, and 011. Station 2 was missing because it is the site of erosion and also vandalism, yeah? Notice that it is the least inhabited, is least developed. Little development happens here, but this is actually least developed, Station 2. So average wind speed is about 1.5 meters per second in this area. The significant wave height averages about 0.3 meters, and the longshore current direction is generally to the west. So beaches, looking at Station 1 for the period 2011 to 2018, we have on the bottom left, we have the beach profile graphs. Each different color represents a different month within that time period. We have on the y-axis, we have elevation in meters. On the x-axis, we have distance in meters. So BM means benchmark, and that is a permanent structure on the backshore that we take measurements from every time we go to take profiles. The profiles are taken at 4-meter increments from the benchmark into the water up to about 1.5 meters, which is about a safe wading height for our staff and colleagues. So we actually see the different changes along the beach slope with the berms and scarps at different points in time during this period. To the right-hand side, the profiles are referenced to mean sea level. So where it is we actually have data, GPS data for this. So the bottom right-hand graph shows the changes in beach volume per meter. So the red line depicts change in beach volume, and the black line shows linear change in beach width. So we can actually see that even though the beach volume might overall be increasing, there is fluctuation. Similarly, for the beach width, there shows a decrease, but there's also fluctuation. This is a relatively short period in time, so a longer term data set could actually show something totally different to this. So it's important to be consistent with data collection, especially when you deal with coastal dynamics and the shoreline. So looking at Station 3, moving centrally, the benchmark, the profile, this profile shows much less change and fluctuation with the beach face as compared to the western stations, which are more exposed to the wave energy from the Gulf. We also see with the changes with the beach width and beach volume, there is generally not much change to the naked eye, but there is a slight decrease with the beach width over time. Grain size, the sediments were collected in 2013, and the D50, the average grain size was 0.22 millimeters. And as expected, the lower beach sample points were very poorly sorted, but the upper beach and the mid beach were moderately to well sorted. Sand. So moving to the stability status, Station 2, we have the least amount of data because of erosion and also vandalism. But to the east, which is closest to the headland, Station 011, this actually shows dynamic equilibrium, and the other stations show the different rates of erosion during those years. Now, it's important to note that the frequency of data collection can be monthly, quarterly, or even biannually. It also depends on the resources, financial, physical, time that we have to execute this project. And from the data over the years, this is what the data shows. Now moving to, this is the DSAS program in ArcGIS, Digital Shoreline Analysis System. So this is supposed to actually show the table with the different erosion and accretion rates. The bottom left-hand box shows the southwestern peninsula of Trinidad. The red area shows the area of interest along that southwestern peninsula. The colorful satellite imagery here shows the entire, from east of Granville, which is east of Cedros, and then Columbus Bay, But CDRUS is located, our area of interest is located around right here where it is that we have physical benchmarks. So on the computer, you actually can have many more transects depending on the distances you choose. But the ground truth, you actually see some corroboration with what we have on the ground and what the computer shoots out. So on the eastern part of our study area, east of 011, we have the highest rates of erosion from DSAS, and moving west, the erosion decreases. We would need to add additional stations to actually verify what the computer is finding. But different variables would give us different results. So some conclusions we have is that erosion is occurring at Bonas area in the immediate section where we have our physical benchmarks and also where the computer calculates the different shoreline movements. And the beach is definitely being narrowed, and we have fine-grained sand here. Recommendations, we would need to put additional benchmarks to actually ground truth and confirm. Beach stabilization would be important, especially since this road, this community, connects two very important fishing communities in the southwestern peninsula of Trinidad. Dune creation would be suggested, vegetated dunes, which would absorb the impact of the coastal processes, especially at this part, because on the southwestern peninsula in Trinidad, the wave energies, the coastal processes are somewhat different than what you would expect for the normal coastal processes during any calendar year. We would like to acknowledge KIOS, COICA, ACS, GAMA, the Government of Trinidad and Tobago, and the IMA. And this is my end of my presentation. This is my colleague information, Mr. Iran Mohammed, and we can be reached at this contact here. So thank you for listening. Any question? Right. So there is a thrust to actually increase the amount of public-private partnerships to basically fill in the gaps with data collection. Because when it is we have, at a state level, we focus resources on different areas of the shoreline that would be most important depending on the different criteria, whether it be socioeconomics, tourism, environmental sensitivity, etc. But there are some initiatives which currently exist, but there is a thrust to improve and fill any data gaps. Which channels? Well, in some instances, the erosion in the zone have increased, and in other areas, it has decreased. Erosion over, well, the 10 years is not a very long period of time for observations along the coastline, but it gives an idea of what you can expect. But coupled with the phenomenon of climate change, which impacts sea level rise and coastal inundation or the coastal processes, then the erosion itself has been exacerbated at certain points beyond the projected erosion rates which we have. And it's a bit, it's a cause for concern in especially in different fishing communities, like Columbus Bay. Actually, and that is one of the main projects you would see would be the Sandy Shorelines project in collaboration with the government of South Korea. They are at the forefront, and they have partnered with different Caribbean countries to actually improve how we collect data to create a standardized data collection within the region to try to not mitigate, but to better prepare and adapt for any fallout from climate change, especially on the Caribbean countries. Well, you put me in a little rough spot here. All right, being real, vandalism is not just graffiti. In that example, that area, that is almost no development at Station 2, highly vegetated, so it's basically pristine, but also there is no one there. So there are no eyes, basically, to put it simply. So you can get away with almost anything in areas like that in any part of the world along any shoreline. So it's not really graffiti or paint spraying up. People actually remove proper infrastructure that are designed for monitoring, where you would encourage human activity. So what they want is no activity, so they can conduct activities of their own. So we cannot really prevent that. We can talk to get assistance, but again, resources are very limited, and different state agencies focus their resources and prioritize where they need to be. So we would still continue the discourse and hope for the best. Yeah. All right, thank you very much.